Now these are the solutions to the quiz at the end of lesson 6.1. Now number 1, we have the EMF is proportional to the rate of change of flux. And so since the flux equals B times A, and since the area is fixed, that equals the rate of change of B. So in that graph of B, we are looking for where the slope is the steepest, and is steepest at C, and that is larger than at B, which is larger than at A, so that is C. Now number 2, we have to consider the magnetic field due to that current. Now above the wire, using our right-hand grip rule, we can see that the magnetic field goes into the screen. Now it is increasing because the ring is approaching, so the induced current causes a magnetic field out of the screen, and that means counterclockwise, so that is B. And then number 3, that is E, because all of those things happen when you have that loop moving through a magnetic field that is changing. So number 4, we have an initial radius of 0.11 meters, and then a final radius of 0.3 meters. We have magnetic field of 0.27 Tesla, and the time is 0.08 seconds, and we have an angle of 0, so cos of that 0 is 1. So firstly, we have the area to begin with is pi Ri squared, and that is going to be pi times 0.11 squared, 0.038 square meters, and the final, which is pi Rf squared, will be 0.2827 square meters. So the change in flux is going to be the magnetic field, which is constant, times the change in area. And that is going to be this change in area, which is 0.2827 minus 0.038 times 0.27, which is 0.2447 times 0.27. That will be 0.066 Webers. So now the EMF is change in phi over the time interval, 0.066 over 0.08, and that gives us 0.83 volts. And then the current, which is that EMF over R, is going to be 0.83 over 0.7, so we have 1.2 amps. Now, question 5, we have a change of flux of 5 Webers. We have a time interval of 0.05 seconds. So EMF is 0.05 is going to be 100 volts, and the resistance is just EMF over the current is 5.3 ohms. Now number 6, we have the area is 0.032 square meters. We have an angle of 0, so cos of that is 1. We have an initial field of 1.5 Tesla, and then it changes to 0, so the change in B would be 1.5 Tesla in size. So the EMF is d phi dt. Now we know that d phi is just A times dB equals 0.032 times 1.5 equals 0.048 Webers. So we know that E equals d phi dt, so dt must equal delta phi over E, which is 0.048 over 0.01 volts, and that gives us 4.8 seconds as the minimum time to allow that flux to die down to zero. Now 7, we have area is 0.35 meters times 0.55 meters, and that is 0.1925 square meters. We have an initial field is 2.1 Tesla. We have an angle of 65 degrees, and we have the final magnetic field is 0. So that, of course, means our delta B equals 2.1. So delta phi A times delta B times, sorry, I should have not forgotten that that is cos of 65. So that is 0.1925 times 2.1 times cos of 65, and that comes out to be 0.17 Webers. Then we know that delta T equals 0.45 seconds, so we have EMF equals delta phi delta T equals 0.17 over 0.45 equals 0.38 volts. Now for B, if I can fit it in there, we have the same EMF, 0.38 volts. And we know that, and we are back to our original field of 2.1 Tesla, so we have E equals delta phi delta T is B times delta A times cos 65 over delta T. So that is 0.38. So we have, this is the bit we want to keep. We have the change in A, so the rate of change of the area has to be 0.38 over 2.1 cos 65, and that is 0.43 square meters per second. And then finally, number 8, we have EMF of 0.8 volts and a current of 3.2 amps. Now we have the length of wire, let's say that L, and we're going to make it into the circumference of a circle at first, which is 2 pi r. So we know from that then that the radius must be the length, whatever it was, over 2 pi. Then the area equals pi r squared, which is pi L squared over 4 pi squared. That cancels. We are left with L squared over 4 pi. Now for the square, the length of each side is L over 4, so the area equals L squared over 16. Now we know that the EMF is proportional to the change in flux, which is proportional to the area. So we're going to do this as ratios. The new area, which is the square, over the old area, is going to be L squared over 16 over L squared over 4 pi equals L squared over 16 times 4 pi over L squared. So that cancels, this gives a 4. So we have pi over 4, which is about 0.785 as our ratio. So that means that the new EMF is 0.785 times the old EMF, which was 0.8, so that is 0.63, and the new current, which is in the same ratio, is 0.785 times 3.2, and that is 2.5 amps.